Methods of fossil formation. Fossils are the remains or traces of prehistoric plants and animals which are buried and preserved in sedimentary rock or trapped in organic matter. The hard, indigestible skeletons and shells of animals and the woody material of plants are usually the best preserved. Fossils of organisms made of soft tissue that decays readily are rarer. Many factors can influence how fossils are preserved. The fossilization of an organism depends on the chemistry of the environment and on the biochemical makeup of the organism. As a result, not all organisms in a community will be preserved. Plants are most commonly fossilized through carbonization. In this process, the mobile oils in the plant's organic matter are leached out and the remaining matter is reduced to a carbon film. Plants have an inner structure of rigid organic walls that may be preserved in this manner, revealing the framework of the original cells. Animals' soft tissue has a less rigid cellular structure and is rarely preserved through carbonization. Another common mode of preservation of plants is petrification, which is the crystallization of minerals inside cells. One of the best known forms of petrification is silicification, a process in which silica-rich fluids enter the plant cells and crystallize, making the cells appear to have turned to stone, petrified. Petrification may also occur in animals when minerals such as calcite, silica, or iron fill the pores and cavities of fossil shells or bones. Replacement fossilization occurs when an organism is buried in the mud and its remains are replaced by N-sulfide, pyrite, or phosphate apatite minerals. This process may replace soft tissue, preserving rarely seen details of the organism's anatomy. Paleontologists have used mild acids to etch the photophaetized fossil remains of ancient fish found in Brazil to reveal structures such as gills and muscles. Many animal shells are composed of the mineral aragonite, a form of calcium carbonate that breaks down over millions of years to form the more stable mineral calcite. This method of preservation, called recrystallization, destroys the microscopic details of the shells but does not change the overall shape. Snail shells and bivalve shells from the Jurassic period and later are still composed principally of aragonite. Most older shells that have been preserved have recrystallized to calcite. The soft tissue of animals are preserved only under extremely unusual conditions, and the preserved tissue usually lasts for only a short geological period. In the Siberian permafrost, the earth that remains frozen year-round, for example, entire mammoths have been preserved in ice for thousands of years. The remains of the mammoths' last meals have sometimes been preserved in the stomachs, allowing paleontologists to study the animal's diet. Another process, called mummification, may occur in hot, arid climates, which can dehydrate organisms before their soft tissue has decayed fully. The skin itself is preserved for only a short time, but the impression of the skin in the surrounding sediment can be preserved much longer if the sediment turns to rock. Paleontologists have found skin impressions of dinosaurs preserved by this method. Besides rock preservation, when whole organisms become trapped and preserved in organic matter, such as amber, natural asphalt, or pea, they can be preserved for millions of years with details of their soft tissue, such as muscles and hair-like bristles, still intact. Acidic conditions may slowly dissolve away the skeletons of fossil animals preserved in rock, leaving a space where the organism used to be. The impression that is left in the rock becomes a mold. This process commonly occurs in fossil shells where the calcite shell dissolves easily. The impression of the outside of the shell is the external mold. Sometimes the inside of the shell is filled with sediment before the shell is dissolved, leaving an internal impression of the shell, called the internal mold. If the space where the shell used to be is then filled with a new mineral, the replica of the shell forms a cast. At other times, when animals walk through soft sediment such as mud, their feet, tails, and other body parts leave impressions that may harden and become preserved. When such an impression is filled with a different sediment, the impression forms a mold, and the sediment that fills the mold forms a cast. Molds and casts of dinosaur tracks are relatively common and help paleontologists understand how these creatures moved.